So for this part of the review, we are going to go over identifying different types of angles. And as we did this in class, there are lots of different correct answers. So I'm going to do a few for each of these. What I suggested in class is you actually use colored pen and kind of go over them. So I'm going to do a few here. So an acute angle means an angle less than 90 degrees in measure. So for instance, I can see that that is an acute angle. And I can call that angle Q, P, R, or I can call it angle R, P, Q. But since P is the vertex, I have to use P as the middle letter. Since there's a 3 there, I can also call it angle 3, but the directions said identify the angles using letters. Another correct answer for this would have been angle MON or angle NMO. Once again, I could have called it angle 7, but the directions say use only using letters. So that would not be correct way to write the answer on a test. And let's do one more acute angle. I'm going to do angle OMP, which, by the way, I could call OMQ, or I could call it PMO, or I could call it QMO. Any of those would work. So now we're going to move on to an obtuse angle. So an obtuse angle is greater than 90 degrees. So it's sometimes difficult to see these. Sometimes I go back to the acute angles I did and find another angle near it. And we'll talk about when we get to that to linear pairs. So for instance, I had done this angle here for my acute angle, right? My first one. So then there's this angle is obtuse. And I can call that angle QPO. I can call it QPN. I can call it OPQ or NPQ. Another example here of an obtuse angle would be angle MOR, or I could call it ROM. Now a linear pair means two angles that form a line, so they're going to be adjacent. And as I said earlier, sometimes one of my usually these will end up being one of them is acute and one of them is obtuse. So sometimes the easiest way to do it is to color over a line. Do that in black. I'm going to go over that in a color minute. And if you remember earlier, we found this angle here was one of our acute angles when we had to find. And the angle is actually the space in between those rays. And then an obtuse angle would have been, so basically on the linear pair, you see that they're adjacent, so they share a side, and the non-shared side makes a straight line. So in this example, my linear pair, and I can call these lots of different things. I'm going to call this angle R, P, Q, and angle Q, P, O. I also could have called it QPN. Okay? I'm going to do another linear pair. With that line, I'm going to do this line. So there's two different linear pairs here. If I draw this ray, there's going to be this linear pair, but there's no identified point here. So I would rather have it where there's an identified point. So this is a line, there's a ray that comes off that line, breaks it into two angles. So if you need me to highlight for you again, this is one of the angles, this is the other. Okay, so I'm going to call this angle MPO, although I could have called it MPN, and angle QPO. So that's for my linear pair. For vertical angles you want to think of, they make an X. So I'm going to look here and I'm going to find two lines that make an X. Okay? So that's my vertical angles. And I have two sets of vertical angles. Vertical angles are angles that are then kind of opposite each other. So that's one set in orange. And there's another set here. So I want a set of vertical angles. Okay? So my orange angles here are MPO, although I could call it OPM or MPM, and QPR. You want to remember that vertical angles are also congruent, and that's the congruency. My other set of vertical angles here, angle MPR, and I'm going to do OPQ, although I could have called this NPQ. They're congruent. You'll also notice when you do this, typically one set of vertical angles is acute and one is obtuse. And later on, you're going to have to find some other angles, so you might want to keep that in mind. One set is acute and one set is obtuse. A straight angle is basically a straight line. The difference being when we name a line, we use 2 points and we use the line symbol. When we name an angle, sorry for that bad handwriting, we use 3 points and we use the angle symbol. So this straight angle, I could call it angle NOP. If I were naming the line, I would only use 2 letters and I would use the symbol over it. I think we have a few others on here that also deal with identifying angles, so let's talk about that. Use the drawing at the left to solve the next questions. A pair of obtuse vertical angles. When I said earlier, when I have vertical angles, usually I have one set that's acute and one set that's obtuse. So I'm going to first find a set of vertical angles. So basically 2 lines that intersect. And I'm going to highlight these in. Sometimes when I highlight, it helps me see. Okay? And I can see that the set that is acute is the pink set Hold for a second. Some student just walked in and is answering me a question. Because I'm videoing, don't talk too loud. You're going to be on YouTube. Sure. So sorry for that. So, you want to be part of the video real quick? You don't want to tell me which is the vertical angles, or these are vertical angles, right? Which is the acute and which is the obtuse. Find the pair of obtuse. Just touch them. You don't actually have to talk if you don't want to talk. And you're not, the screen is just recording, so nobody will know who came in. Okay, the two that are kind of pink, those are my obtuse ones, right?
Yeah.
And I could call those angle B, C, G, and D, C, F. You just did problem 15 on the review. Oh, thank you. And two non-adjacent complementary angles. Well, complementary means they add up to 90 degrees. And I want ones that are not adjacent. I see that I have two angles labeled 50. So I'm just going to kind of actually highlight those for a second. So I want ones that are not adjacent. So that's going to be 90, that's going to be 50. If this is 90 here, that means that that angle is 40 degrees. Correct? But I can't have this angle and this angle because they're adjacent. But I can have this angle and this angle. So I can have and I can have this angle. I'm going to talk about this for a second. So my two non-adjacent angles are angles C, G, F, and angle D, E, F. So I want to point something out here. You can see that these two angles actually look like they have a common ray or common side because they're going to overlap. But remember, when we name rays, the first letter has to be the vertex. So this ray, this pink ray, is actually ray GF. And the other ray, or let's actually name it all the way down the side here. And I'm going to color code it here. This ray would be ray GE. This other ray, the black ray, is actually ray EG. They're not actually the same ray because they have different endpoints. So even though they overlap, these angles are not considered adjacent. They're adjacent when one side is the same ray. So that the one side in common is the same ray. So that's a good review of looking at diagrams and identifying rays. Actually, not just rays, identifying any of these things that they ask you, linear pairs, adjacent, obtuse, acute. That should help you greatly with the review.